Hello all, welcome to i-tutor Academy. In today's session, we will start with the Unit 8, that is subsection 6 of Mmpc 009, that is Program Evaluation and Review Technique Report. And in last video, we just discussed till 8.5. Please refer that. And what is critical part we discussed in last session, and this is Program Evaluation and Review Technique. So CPM is and that is critical path method is an effective tool for project planning and control when activity time are known with a certainty. So however, in certain project like research and development projects, it seems unrealistic assume that we can know with certainty the time duration in which the activities can be completed. In such a case, PERT can be used. The time estimates in PERT, so that is most likely time, the time which is taken most frequently by the activity, the time by which activity can be completed if everything went well, the time by which the activity will get completed even under adverse condition, and from the above time estimate expected time of the activity J, that is computed using following relationship. Okay, so here is an equation. The expected time for an activity represents the average time it would take if the activity is performed over and over again. So it is different from most likely time. And the above relationship is based on the fact that the probability distribution function of the activity time can be approximated by a beta distribution, which is of the shape shown in figure. Here is the figure, there is a chart based figure, so please refer this from your Mmpc 009 unit 8 subsection 6. Okay, and next is time of the project completion. And unlike CPM, in the case when there is uncertainty in activity time, it is not possible to compute the time of completion of the project with certainty. So instead, we shall estimate the expected time and variance of the project completion time. And in the expected project completion time, T can be computed as the length of the critical path in the CPM when activity times are replaced by the expected time of the activity. As in the case of example 8.2, TER as the same activity time. So in last figure we referred that, and the expected time of the completion of the project is 17 weeks. So further, a crude estimate of the variance of the completion time can be obtained by the adding the variance of the activity on the critical path, that is V completion time, that is equal to sum of variance of the activities on the critical path. Okay, so here is an equation, please refer that. The next section is time cost relationship and project crashing. So parallelly use your study material, it will help you for your more understanding with this video. Okay, in addition to the time management, cost plays an important role in any project. So the project cost can be classified in two groups, that is direct activity cost and indirect project cost. Direct activity cost are those components of the cost which can be directly linked with the activity, and thus direct labor, material consumed, rental charges for the equipment, etc. will form part of this cost. Usually, the activity duration can be reduced by increasing the direct activity cost. For example, by asking the labor to work with overtime or with the efficiency bonus for the fast work, etc. So here is time cost relationship for an activity. A chart diagram is here. Okay. On the other hand, indirect costs are the overhead associated with the entire project, including loss of revenue or benefit due to the late completion of the project. This cost will decrease directly with the decrease in the project completion time. An optimal project completion time will be the time for which sum of these two costs is minimum. To obtain the optimal time, we have to compute direct activities cost when project duration is reduced by 1 unit time each time. This is called project crashing. That is, we shall explain the project crashing by the following simple example. So here is example 8.3, data for example 3 is here. So please refer this. It will get a solution also here. Step 1 for the solution, and You just refer this, you will get an idea through this example. And step through 2 and 3 for the solution. Okay, and the table also here, project crashing, and that's about this section. And next is resource allocation. How to do this resource allocation? The analysis up to this point has been based on the assumption that if its predecessors were completed, an activity could, again, underlying this assumption is the fact that sufficient resources will be available to start activities simultaneously. However, in actual practice, some of the resources may be available in limited quantities. An example of such resources are expensive equipment, skilled manpower, and finance, etc. For example, let each of the activities A, B, C, D, E in the example 8.3 require 2 carpenters, and let there is only 4 carpenters available. So here is an example. So step 1, there is allocate resource seriously in time. Okay, step 2 is when several activity compete for the same resource, give preference to the activities with the least slack. Recompute the slacks in all the activities. And step 3 is reschedule non-critical activities if possible to free resources for scheduling critical or non-slack activities. So here is table 6, resource allocation. Okay, that's about this. And the next is project updating and monitoring. What is project updating and monitoring? For effective use of the above technique, it is essential that project progress should be continuously monitored, and when there is a change in time schedule of any activity, the project network should be updated and a new time schedule finalized. So nowadays, with the most of the computers well written CPM or PERT packages, including project crashing and resource allocation, are available. So these packages will provide all the necessary information needed for the efficient project management. And summary is here. Project are non-repetitive large tasks. A systematic way of describing a project is through identification of activities and their interrelationship. This interrelationship can be visualized using arrow diagram or networks, and project management deal with the time scheduling and resource allocation for these activities. And if the activity time are deterministic, then critical path method can be used as a systematic method to compute early start and late start time of activities and to identify critical activities. And the slacks associated with each activity can be used for better control of the project. When activity time are probabilistic, PERT is an effective tool. In this method, 3 time estimates are made for each activity, and these are used to compute expected project completion time and its variance. And project duration can be reduced by incurring additional cost in executing activity. And a project cost time relationship can be obtained using project crashing. This can also be used to obtain the optimal project duration, and resource allocation is one of the major problems in project management. A simple heuristic is suggested to handle this problem. Okay, so this is a summary of this unit and keyword section. If you feel any words are difficult, you just refer these sections. You will get the explanation of each. And next is self-assessment exercise. So here is around seven questions are here, so please try to do it. It's very important. It will help you for your time in examination, like your assignment. You can expect question from this side also. In between any doubts, you can contact us anytime. So this is about unit 8. For more MBA videos, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents Ignoumbajourney complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 217 885.